In this video, we're going to apply our understanding of the unit circle in order to evaluate some exact trig ratios. Now, if you haven't seen the first video on what the unit circle is, or the unit circle basics, I'll put the link in the description because you should watch that before looking at this one. Now, suppose we're asked to evaluate sine of 3 pi on 2. This is not something that I could just simply look at my table of values and know the answer. So let's imagine where 3 pi on 2 is. Well, this would be 1 pi on 2, that would be a 2 pi on 2, and this would be 3 pi on 2. So I need to draw a straight line out and think, what would that coordinate be? Well, that coordinate would be, if this is a length of 1, 0, negative 1. So from this I can infer, remembering that any point on the circle is going to be cos theta, sine theta. Well, sine of 3 pi on 2 must be negative 1. So it's as simple as saying sine of 3 pi on 2 is negative 1. I could also infer, not that it's asked for it, but cos of 3 pi on 2 happens to be 0. And if we're thinking, what would the tangent be? Well, tan of theta, or in this case 3 pi on 2, well, that's going to be equal to sine over cos. So negative 1 over 0. And of course we know that to be undefined because we can't divide by 0. So that's how we can use our basic understanding of what the unit circle is in order to solve for some exact values. Let's try a few more. So now would be a good time to pause the video and see if you can give these two a go. We're about to do the solution, so hopefully you've paused the video and we'll try it now. So we're after cos of 5 pi on 2. And at first we might think, well, what does 5 pi on 2 look like? We could think of 5 pi on 2 as equal to 2 pi plus pi on 2. Because 5 lots of pi on 2, or if you think 5 over 2 is 2.5 pi. So another way to do that would be that it's 4 pi on 2 plus 1 more pi on 2. But if you can't see that, that's okay. We can just go around and say 1, 2, 3, 4, 5 pi on 2. So I know that I'm after that point there. The coordinate of that point is 0, 1, because this is the unit circle. So I know that cos of 5 pi on 2 is 0, and sine of 5 pi on 2 is 1. So my answer here, cos of 5 pi on 2, is equal to 0. Now we can think of the same thing when we get to tan of 15 pi on 2. If we think 15 pi on 2, well, 15 over 2 is 7.5. So I could think of that as 7.5 pi. So 1, 2, 3, 4, 5, 6, 7.5. So we're down at the bottom here. So I know that cos of 7.5 pi, or cos of 15 pi on 2, is going to be 0, because that's the x coordinate. And sine of that will be negative 1. So if I wanted to find tan of an angle, in this case 15 pi on 2, I know that it's equal to sine of that angle over cos. And so if I look at my coordinate, I've got negative 1 divided by 0. And I can see that the answer here is undefined. What we can always tell is that if I've got tan of a measure of pi on 2, the answer will always be undefined because the cosine of anything that's a measure of pi on 2 will always be 0. Now, these kinds of questions can get a little bit more difficult when we're asked to find something like 11 pi on 6. Or we might have a measure of pi on 4 or pi on 3, Basically, we've got something that isn't simply a measure of pi on 2. So sine of 11 pi on 6, we need to think, how might I represent that angle, 11 pi over 6, as a measure of 2 pi? And so when I'm thinking about that, the nearest whole unit of pi would be 12 pi on 6. So 11 pi on 6, I think, well, that would be 12 pi on 6 minus 1 pi on 6. So I haven't changed the value, just the way that I'm representing it. And so I'm thinking, okay, well, that's sine of this thing here is 2 pi minus pi on 6. Now, that's telling me that 11 pi on 6 is actually down here. Remember that this quadrant is the 2 pi minus theta quadrant. It's where cosine is positive, but everything else is negative. So sine of 2 pi minus pi on 6 is actually just negative sine of pi on 6. So I'm hoping you can see at this point that we're just using our understanding of CAST, of cast, and our trig identities described in our previous video. So I simply need this to be negative sine of pi on 6. Well, this sine of pi on 6, I'll use my table of values to go to pi on 6, sine, say, oh, that's going to be 1/2. So the answer to this question here is going to be negative 1/2. So now's a good time to test yourself and see how well you know this concept. So I'll get you to pause the video and attempt these two problems. Remember that what we're looking to do is think, how can I represent that very odd or strange angle as the nearest whole unit of pi? So something like 5 pi on 4, I might think, what's the nearest whole unit of pi, the nearest lot of 4 pi on 4, and represent the angle that way. Once I've done that, I can think about those identities, where those quadrants come into play, and try to represent cos of this strange angle as either positive or negative cos of a reference angle. Same thing with tan. So pause the video, give it a go, and I'll go through the answer in a moment. Okay, so let's look at 5 pi on 4 and think, how might I represent this? Well, the nearest whole number would be 4 pi on 4. So that leaves 4 pi on 4 with 1 remainder. So this is equal to pi plus pi on 4. So I've got to think to myself, the question is actually asking, what is the cosine of pi plus pi on 4? Now, recall that on our unit circle, we've got some quadrants here. So this is my reference angle. Everything's nice and positive. Here in my second quadrant, I get to that by doing pi minus an angle. Now only sine is positive there. My third quadrant is pi plus the angle, and my fourth quadrant is 2 pi minus the angle. You could also do this as just minus an angle. So in our third quadrant, only tan is positive, and in our fourth quadrant, cos is positive. And so I can see here that this pi plus an angle is taking me into the third quadrant. So cos of pi plus pi on 4 is actually just equal to cos of pi on 4 if it were negative. So negative cos of pi on 4. Now I could either use my hand trick, or I could look to my table of values and recall that cos of pi on 4 is 1 on root 2. Now that's the same as root 2 on 2. So it's always nice to rationalize it. You don't have to, but we would say that this is negative root 2 on 2. If you're not sure how to rationalize, I'll just do that as a little side note here. 1 on root 2 has a surd as a denominator. So it's got an irrational number, a square root of 2 as a denominator. So to fix that, we just multiply by 1. Now 1 can take many forms because it can be anything divided by itself. So the square root of 2 times the square root of 2 means that this is just equal to 2 on the bottom, and 1 times root 2 is just root 2. So we know that root 2 on 2 and 1 on root 2 have the same value. It's just that this one here is a little bit easier for computers to calculate because it's not dividing by an irrational number. So you can test it on a calculator if you're unsure, but you can see they are the same value. Either answer is correct. So cos of 5 pi on 4 is going to be negative root 2 on 2. We first represented the angle as something that's to the nearest unit of pi. We recognize that pi plus an angle took us into the third quadrant, and we rewrote our ratio as cos of that angle, but being negative. So let's look at tan of 52 pi on 6. Well, the nearest multiple of 6 there could either be 54 pi or 48 pi. Well, let's imagine that we've got 52 pi on 6 is equal to 48 pi on 6. Oops, sorry about that. It's equal to 48 pi on 6 plus 4 pi on 6. So this is going to be, well, 6 times what equals 48, so that's going to be 8 times. So I've got 8 pi plus 4 pi on 6. Well, 8 pi is just a measure of 2 pi. If we imagine a little unit circle here, and I said 1 pi, 2 pi, 3, 4, 5, 6, 7, 8, we're right back at the start. So 8 pi can just be ignored. And 4 pi on 6, of course, is just 2 pi on 3. So this is another somewhat difficult one to think about, because 2 pi on 3 isn't something that would appear in my table of exact values. It's not a reference angle because it's more than 90 degrees. So 2 pi on 3 also needs to be thought of something as in terms of a reference angle. And we can think of 2 pi on 3, which is just out here, as being tan of pi, so that's 3 pi on 3, minus pi on 3. Now remember that second quadrant, only s is positive, so tan of pi minus pi on 3, we're saying that's actually just negative tan pi on 3. So using my table of exact values, I can think, oh, what is tan pi on 3? And referencing that table, I can find that tan of pi on 3 is equal to root 3 on 2. And that's got to be negative because it's in the second quadrant. So the answer here would be negative root 3 on 2. Now we can extend our understanding here in some basic application questions in which we never actually know the angle. So it says here if sine of theta equals 0.4, so there's some context that I need to know. Cos of x, well, x is a different angle to theta, so that's going to be important. But cos of x is 0.7, and the tangent of alpha, again a different angle here, is 1.2. So what we're saying here is 3 seemingly unrelated pieces of information. There's 3 different angles. And we're being asked to evaluate some other random angles. So at first glance, these are unrelated. However, we can think of a few things. So we've got our little unit circle here, and just as a maybe shorthand reminder, we can think that this is just the angle, this is pi minus the angle, this is pi plus the angle, and this is 2 pi minus the angle. So we're asked here to find what would sine of pi plus theta be? Well, pi plus theta takes me into this quadrant there. So I think, okay, sine plus theta is equal to minus sine theta. Now you'll see that in your notes. I know it's a little small, but if I zoom in on this image, you can see it's just there. So what we can tell is that sine of pi plus theta is actually in the third quadrant, so it's equal to minus sine of theta. And I know what sine of theta is. It's 0.4. So the answer here is going to be 0.4, but there's that negative there. So the answer here is just minus 0.4. Now, let's see if you can take the same approach, pause the video, and find what is the answer to tan of pi plus alpha. So, tan of pi plus alpha, well, again, we're in this quadrant here, in that third quadrant. So, tan is positive there. Tan of pi plus alpha is just equal to tan of alpha. And the piece of context I got previously was that that's just going to be 1.2. So we've been looking at ratios, but now we're going to have a look at those trig identities that you were asked to memorize last video. So we're told that if sine theta equals 3 over 10 and cos alpha equals 4 over 5. So following if, we normally get some context. So here's some background context that we know. We're asked to find, and what are we asked to find? Sine pi on 2 plus alpha and cos pi on 2 plus theta. Now here's where most people go wrong with this question. They don't properly pay attention to the context that this is sine theta and we're asked to find something in terms of sine alpha. So this is not going to be done the same way we did previously by finding what quadrant it's in. Rather, we need to consider our trig identities. Now one of the identities that we know is that sine of pi on 2 plus or minus any angle, so plus or minus any angle, is just going to be cos of that angle. And we also know that the cosine of pi on 2 plus an angle is going to be sine of that angle. The cosine of pi on 2 minus an angle is also going to be sine. Now I've just made a mistake here. Cos of pi on 2 plus theta is actually going to be minus sine. So apologies on that one, I nearly made a mistake. We can actually prove these, and I'll jump into Desmos to prove that for you now. So what we have is the red line, which is the graph of sine theta, or sine x, and the blue line, which is the graph of cos x. So watch what happens if I translate pi on 2 in either direction. So we'll start with pi on 2 plus x. So just down the bottom here, I'll do pi divided by 2 plus x. Whoops, let's just fix that up. And so now we can see that they overlap. And that's because sine of pi on 2 plus x is the same as cos x. Remember, we can just interchange that x with theta. Likewise, if I change that to a minus, we get the same thing. So that is, if I reflect and then translate to the left pi on 2, I'm going to get the same thing. So sine of pi on 2 plus or minus an angle is the cosine of that angle. So they're the same. There's another little proof we can do using a triangle, and might do that for you later. Now, looking at the cosine of x, if I did pi over 2, then I did plus x, you can see that these aren't the same at all. However, if we reflect x, if we flip that about the x-axis, so if we put a minus here, we can see now they are the same. So cos of pi on 2 plus x is the same as minus sine theta. If we go back to a regular sine, cos of pi on 2 minus x, you can see is exactly the same as sine x. So that's where these exact values, or these exact trig identities, I suppose, come from. So it's good to commit them to memory. So now that we know that information, how do we put it into practice? We're asked to find sine of pi on 2 plus theta. And we know that sine of plus alpha, we know that sine of pi on 2 plus an angle is the same as cos of that angle. So this thing here is the same as cos alpha. Well, we've got that contextual information there. That's equal to 4 over 5. So I can say, oh, that's simply equal to 4 over 5. So sine of pi on 2 plus alpha is equal to 4/5. Cos of pi on 2 plus theta, well, this is pi on 2 plus something, so this is going to be equal to minus sine theta. Well, what is sine theta? Sine theta is 3/10. So this is negative 3/10. And that's the answer for that question. Now, it may not look like it, but this question here actually uses the same principles as the question previously. It's a test on whether you know your trig identities. Now let's have a look at the context here. We're told that we're given sine x equals 3/5. And we know that x is in between pi on 2 and pi. Well, what does that look like? It means it's in this quadrant here, because that's pi on 2 and that's pi. So I know we're in the S quadrant. We're asked to find tan of x. So we're asked to find what is the tangent of x. So it is actually, as I mentioned, trig identities is what we need to know, but because tan is involved, and previously we only talked about the sine and cosine trig identities, we need to remember that sine squared theta plus cos squared theta equals 1. Now, if you haven't seen this notation before, it simply means that we work out sine theta and then we square it. This is just a shorthand way of writing the long way here. So sine theta squared plus cos theta squared is equal to 1. And the context that we have for this is that sine x is 3/5. So I'm saying 3/5 squared plus whatever cos theta is squared is equal to 1. Well, we can evaluate this. So 3/5 squared is 9 over 25. Now I know that that's plus cos theta squared is equal to 1. Well, if we minus 9 over 25, we'll get cos squared theta equals 1 minus 9 on 25 is 16 on 25. So we can think of this as saying, okay, 16 on 25, that's because 25 on 25 minus 9 on 25. Now we need to square root both sides. Now I've been using theta here, but remember we should be using x. So we might just fix that now by saying let x equal theta. And then we can resubstitute this in. I can say, okay, well if I square root both sides, then I'll get cos theta is plus or minus the square root of 16 on 25. Well, that's going to be 4/5 because we do the square root of 16 over the square root of 25. Now, the reason why I mentioned about x is because we know that x is between pi on 2 and pi. So cos of theta, would it be positive 4/5 or negative 4/5? It's going to be negative because it's in the second quadrant where cos is negative. So I'm going to say cos of x is negative 4/5. Now why was that important? Well, we were asked to find tan x. And tan x over here is equal to sine x over cos x. That is, it's equal to 3/5 over negative 4/5. So we can simplify this just by getting rid of the denominators of 5, or multiplying by 5 over 5, however you want to say that. And we know that the answer is negative 3/4. So this is quite a difficult question because we need to use a couple of trig identities. Our first one is the Pythag theorem one, and our second one is what is tan. We also needed to pay close attention to what our restriction, or the domain for x, was, because that allowed me to know whether or not this was positive or negative. We're going to finish off this lesson just by looking at the fact that what we learnt previously still holds true. So when you first start learning trig and trig ratios, might be in year 8 or year 9, everything that you learnt is still true. So if I was asked to find sine theta, and I was given this context here, well, what I would say is sine theta is opposite over hypotenuse. So it's going to be that opposite side, 5, divided by the hypotenuse, 13, So sine theta equals 5 over 13. Remember here that we're not asked to find theta, we're asked to find sine theta. So the answer simply is 5 over 13. So you can have a look at doing parts B and part C now. All we need to remember is SOHCAHTOA. So you can pause the video and give these a go. I'm hoping you've given that a go yourself, but let's look at part B. We're asked to find tan theta. Well, that's the opposite over the adjacent. So that's going to be 5 over 12. And the cosine of theta, or cos theta, is just going to be the adjacent over the hypotenuse. So that's where we get that ca from. So cos theta is going to be 12 over 13. Now, there's another way that we can look at what is sine of 90 minus theta. Well, very similarly to before, we could look at that identity and say, oh, pi on 2 minus theta, so sine of pi on 2 minus theta must be cos of theta. And that's true. But let's look at another proof for this. Suppose I had an angle here. And I said, well, let's start with a reference angle theta. And this is my opposite, this is my adjacent, this is my hypotenuse for theta. Well, there exists one more angle in this triangle. Because remember, the angles inside a triangle all add up to 180 degrees. So if I did 180 minus 90, that means that 90 degrees is what this angle and this angle add up to. And so here, I could think this is equal to 90 minus theta. Well, if I think about 90 minus theta, the opposite side is here, the adjacent side is there, because now I'm talking about a different angle. Well, if I'm now just imagining this, sine of 90 minus theta is equal to that opposite, which is A, divided by the hypotenuse, which is H. And I know that A over H is actually cos theta. So that's another little geometric proof, for lack of a better word, or a good geometric explanation for why that's the case. So in part D, when we're asked to find sine of 90 minus theta, that's really just cos theta, which is 12 over 13. So that's 12 over 13. When we're asked to find the cosine of 90 minus theta, so the cosine, that's going to be this divided by that. Oh, that's just sine, because it's O over H. So for part E, we know that our answer is sine theta, which we worked out to be 5 over 13. And finally, tan of 90 minus theta. Well, we need a little bit more room here, so we'll drop this down. Tan of 90 minus theta is sine of 90 minus theta over cos of 90 minus theta. And we already know what these two values are. So we've got 12 over 13 divided by 5 over 13, and that's just going to be 12 over 5. So we're just going to finish up this video with a reminder of what we've looked at. We needed to make sure that we know our exact values, but these exact values, they're only going to be for anything between 0 to 90 degrees. That is, they only work in the first quadrant. In order to apply them properly, we'll need to make sure that we know our 4 quadrants, C, A, S, T. So our reference angles we can see are all positive, but our second quadrant, only sine is positive, and the other two are negative. We know we're in the second quadrant when we're dealing with pi minus theta. Sorry about that. We know we're in the third quadrant when we're in pi plus theta. Now here both sine and cosine are negative, but tan would be positive. We can get to the last quadrant by doing 2 pi minus theta, and in that quadrant only cos is positive. We also needed to apply our trig identities. So we've got pi on 2 plus or minus theta. If that's inside sine, we know it's just cos theta. We've seen these, we know how to apply them. Unfortunately, this is a kind of skill that you just need lots of practice doing. Make sure that you have this committed to memory, so these identities and exact values. You can either do that with look, cover, right, check, the hand trick, or you can use a couple of triangles that help you they're images that help you memorize the same information.